Good morning. We are back and we're going to do some more programming in C. Can't say how well it's going to go, but I'm going to give it my best. I'm going to give it my all. Let's see. Music. Okay. Oh, whoops. Dang it. Forgot to. Oh, well. Who cares? Stream has begun. Okay. Where did we leave off? I don't remember. Actually, I take that back. We are parsing opcodes. Opcodes we will parse. Opcodes we will parse. Excuse me. Excuse me, I gotta blow my nose real quick. I'll be right back. Ba, 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 ba. Okay. Oh, I forgot to file preferences. This needs to go to portrait. There we go. Good morning. Good morning. Did we alert the Discord? We did alert the Discord. Good. Excuse me. Dude, I love my Ember mug so much. That thing is just. The Ember mug must be the best gadget that I've bought for myself or somebody has bought for me in the last 4 years. It's so good. It's so good. I wish they'd sponsor me. Alright. Let's go. Try to figure this out. I don't even remember where we put this thing. We did it there. So chip. I'm also going to open some other tabs here. Let's organize ourselves a little bit. So this is bottom. We'll call this our NeoVim tab for now. Excuse me, NeoVim. Let's go ahead and open another tab. This is going to be our spec tab. Let me go to chip. Make this a little bigger.
Did we just become best friends?
Hey, Kicktails, thanks for subbing. That's very kind of you. Very kind of you. Appreciate you. We got our chip. So let's go ahead and do MPX node. Not node. Live server. Go ahead and fire up that spec doc. If node cooperates, let's go ahead and fire up NeoVim. And then let's add another terminal that's this can be for where we run our program. Just call it PowerShell. So we have spec, PowerShell, NeoVim. I think that's everything we need. There it is. It opened on the other window. So here's our chip. Now, what say you? I say that we need to go into main.c and we need to figure out what is our to-do? We need to parse individual instructions from the binary file. Okay. So how would we read the instructions? So the instructions are stored as 2 bytes, and we have roughly 3,000 or so that are being read in from our program. That's the display section. Okay, here's the instruction section. So I guess the first things first, let's just start with getting the next set of instructions, or I guess it would be the first set of instructions in this case. And how would we do that? I'm also going to copy this. I'm going to put that over here. So we are working at this point in our code. So we were just printing the instructions yesterday. Does that still work? Hopefully it still works. I haven't made any changes. Hey, what's up, Kale? Did you have a good, what was it, Wednesday? Good Wednesday? Yes, trad coder. Hashtag trad coder. I tell you what, man, people have a lot of feelings about you not using AI if you don't want to, and them using AI if they want to. I think people feel very self-conscious if they're using AI instead of coding themselves, and they feel the need to justify their decision a lot. And I just don't understand it. You know, you can be a vibe coder, I can be a trad coder, I can use AI when it suits me, you know what I mean? And we can all live a happy life. It was good. Boss got mad because I was working after my finish time. Miscommunication. Whoopsies. Whoopsies. All right, it unfucked up. So let's try passing a test file. So we'll say run, and let's pass this guy in there. Okay, so there's our instruction set. Let's see if we can get those into. We need to get those in 2 bytes. 2 bytes. Add a little note here. Okay. Oh my gosh, bro. So we need to read 2 bytes at a time. I.e., we basically want to get, what is it, 4? No, 8, sorry. Nibble, and then is that 16? Would help if I could count. No, that's 15. So we need to get 2 bytes like this. And theoretically, right, we're actually going to combine them. We're going to combine 2 bits into, or one, we're going to combine individual bytes into 2 bytes. Then from each of these, we need to extract the different bits, right? So let's just go ahead and map that out, i.e., this might help us reason about this a little closer. So we need a 12-bit 12-bit value that is going to be our memory address, which is essentially the lowest bits of the instruction. The slot machine of slop, yes. Hold on. We need to add that to our analogy app. Where is our analogy app? We need to say, what'd you call it? This. Oh, you did already? Nice. Yes, the slot machines of slop. I vote that one up. Forward deployed prompt jockey. That's a good one too. Hilarious. Hilarious. We're so funny. Until they run into bugs and have no tokens. Yeah. Yep. I mean, yeah. I mean, the AI thing as a whole. I was mowing my grass yesterday, and I kept thinking to myself, this is what I want AI for. I want AI to come mow my grass so I can sit at my desk and write programs. That's what I want, right? It's like when can I say, computer, mow my grass? Shit, computer, mow my grass for me. That would be the real value. Okay, so if we were to go up here, the first 12 bits, the lowest 12 bits would be these guys. So this is 8. For these, we would want all of those. So I think what I'll do is I'll just copy this and say, whoops. This is where we're going to have to get comfortable with bit operations or bitwise operations. So we need, there's 4, 1, 2, 3, 4. And then we want 4 on this side for 12 total. 1, 2, 3, 4. So we need to extract these bits is what we need to pull out. And then this is going to be, copy this again. And this is going to be what? 4. So we only need those. That. And then we need a 4-bit value, the lower 4 bits of the high byte. So that's basically the same thing here, only instead of these 4, right? It's these 4. 1, 2, 3, 4. Yeah. You can use LiDAR scans to map the Gaussian splat and just use the points and train an ML model to power an RC lawnmower. That sounds hard. That sounds hard. I just want a voice activated robot that's AI powered. So I don't know if you watch Linus Tech Tips. but they're doing a project right now where they're like renovating a house, and I saw they had a lawnmower that was basically like a robo-vac that you would have in your house, but for your lawn. That was pretty cool. But I want that. I want it to be as. I want all that. I do LTT's house project is cool. It is very cool. It is. It's awesome. I love it. But I want to be able to do as easy it is to go to Gemini and type in a prompt. I want it to be that easy to ask a robot to do shit for me. That's my aims. Do my dishes, mow my lawn, cook me meals. Let's see, 4-bit value, the upper 4 bits of the low byte of the instruction. Okay. And an 8-bit value, the lowest 8 bytes of the instruction. Sorry, there's a lot of just writing binary right here just so it makes it easier for me to visualize what the heck we're trying to do. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have all the binary that we'd like to get out, right? Now we need to actually get it out. So let's see. This one is basically just applying. So this would be applying a mask. So basically what we'd want to do is, given a piece of binary, we want to mask out these 4 bits. And then we just want to extract whatever's left, right? And then use that as a what do you call it? Use that as our memory address. Now, what bitwise operator would be good for that? I think that would be an AND, right? Because we basically want to say if we basically want to AND together. So let's say our value is, let's say our value is this. I'm trying to come up with a weird. Yeah, let's say our value is this. What we want to do is we want to say, we want to basically set these to 0. These 4 bits we want to set to 0. So the way we would do that is we would say, let's see, mask is we basically want to AND this value. God, I cannot count how many digits there are. So we'd say this. So our mask would be here, here, like that. And then the theory would be then the results would be something like this, where we say, okay, great, this goes to 0, 0, 0, but the rest remain the same. That. So no shifting. We're not having to move anything around because we're going to take the last 12 anyways, but we do need to get rid of these. And this would be an AND. I'm almost 100% certain this would be opper like this. So what AND does in bitwise is AND says if this bit is set and this bit is set, No. Want or? If this bit is set. I don't remember my bitwise operators. Bitwise operations. Okay, so we have and, which basically says yes, this is what we want. And's right. Yeah, and's right. Use and OXF. What's OXF? Hex calculator. No, convert hexadecimal to, yeah. What did you say, F? So F is 11111. Yeah. But we need the higher because we're dealing with 6. So we're dealing with, but we're dealing with 16 bits because we combine 2 bytes together. So I actually think we need this. Man, that the white websites are really making my eyes bleed. Okay, let's I guess let's try a couple things real quick just to test if I actually know what I'm doing. So let's actually give this a test here. Yeah. So let's find a binary to hex converter. Because I could not do that very quickly in my head. So this would be, say we're given this value. I always forget how to copy to my system clipboard. Yeah, exactly. I think that's what you needed. I think that's what we need, Kale. The X. I actually think we need 0, 3 Fs. I think is what we need. But I could be wrong. Okay, so this would be, let's say we're given value int, or I guess uint 8t. No, this would actually be u16t. Value equals this guy. How come I'm not getting any syntax highlighting on my... Huh, weird. Hello, Gunhighs. To see or not to see? That is the question. Yes. Today we are seeing, or we're trying to see today. Oh, we have to put the 0, don't we? We have to put 0x. I also just noticed This needs to call file close on the file pointer. Why the thumbnail looking like those photos of guys holding the fish they captured? It does kind of look like that. I'm proud of it. I'm proud. I haven't got that far though yet, so I can't actually be proud of anything because I haven't actually built anything. So let's go ahead and run this real quick. TSC. Oh, whoops. That's from. Not what I wanted. Ah, dang it. I forgot to friggin'. Int. Ah, dang, dude. There we go. Let's see. Is that correct? So the binary. Sorry, I'm doing this all by hand just to make sure I check my understanding. I know it's kind of painful to watch me struggle through it, but this is the only way I know how to make sense of anything. So if this is our value. Yes, that is correct. So that's the correct value we'd expect in decimal. So that looks good. Now what we want to do is we want to take and we want to AND it by our mask, right? So let's do uint 16 and we'll do masked value will equal our value ANDed by our mask. So our mask is going to be what Kale said, or what he had suggested. Which would be this guy, if I could learn how to copy. Which is going to be for F00. Hold on, I think I have an extra 0 in there, don't I? Why am I getting 614440? Oh, because we actually want to just we just want to do the last 4. I want to do the last 4 bits is what we want to mask. Look at my progress to Archmage. How far along are you? Are you getting close to level 100? Yeah, I think it's just 0. Is it just 0xf? I think it's 0x. I think it's not 0. I think it's, this is what I think the mask should be. I think it should be this. Which this would be. Sorry, I'm using a bunch of online hex to decimal converters because I just like I said, I find it very difficult to do this in my head. I would have to do this by hand if I was going to get it right. Yeah, I think this should be 4095, right? Because that's the max that can be held in a 16-bit integer, right? So that would represent what would that represent in binary? Hex to decimal, or sorry, hex to binary. So this would be oh, okay. I've got my mask backwards. It should be this. It should be that. This is what our mask should be. So then if we do that and we say and, it won't affect any of the existing bits that are set, but it won't set ones that aren't set, and it will nullify any of these that are set, which is what we want. So it's actually the inverse of what I wrote. Okay, so let's go ahead and print the mass value now. And so if the result would be, oops. So the result should be this. And that value is what in decimal? That value is 495. No. This value, sorry. Convert. So that value is what in decimal? 4044. This is 444. I'm thinking about this all in decimal myself. But you're welcome to think about it, I guess, in hex if that works better for you. And this value was what? What was this value? You're making me have to go brush up on more binary. C++ have not been doing. I haven't done bitwise operations basically at all. I think I used them once in Advent of Code a year or two ago. So this is all bringing me back to computer programming 101. I remember having to go to campus and take tests where I had to do this stuff by hand. Yeah, I guess if you work with it enough, it probably becomes more natural. You know, like you can move between the bases, the 2 base, 16 base, 10 base numbers a little bit easier. But for me, it's a little bit of a struggle. So this is the value we were given. We're gonna apply our mask, and then this is the value we're gonna get out. So let's go ahead and print those just to make sure we're not crazy. And this is going to be our mass value. Go ahead and load that up. And what did I do? Oh, forgot a semicolon. Forgot to write the file out. Gosh dang, dude, I have not had enough caffeine, obviously, today. What is happening? Expected, comma or semicolon before print line. What am I missing here? Oh, I freaking deleted the struggle bus. Awesome. So that's what we want. That's what we want. So, okay, so real quick, let's go ahead and let's go ahead and figure out what the mask is going to be for the rest of these things. I think that will make writing the parsing a little bit easier. But it's going to be the same exercise, right? So we need a mask. I don't know what that is there. We need a mask here. We need a mask here. We need a mask here. And in this case, we also need to shift. So this will be operation will be shifting first. So we'll have to shift to the, we want to move all those bits to the right. So shift right, which would be this guy. This is the shift right. And then we need the and. So you have to do that for this one and this one. And this shift needs to happen quite a bit, actually. It needs to go almost 8. Yeah, it needs to go 8 over. And this one needs to go 4 over. So we need to shift 4 and we need to shift 8. And then we also need to apply a mask. But we need to apply the mask value after we shift it. So it needs to actually be... let's separate these a little bit so that we can... So this will be 8. We need a more Majoris mask. What's that? Majoris mask? Oh, that's from Zelda. That's from the Legend of Zelda game? Why are you talking about that, Brett? Also, nice to see you. Let's see. Yes, we need for this one. So I'm just going to keep reusing the same example value. So in this case, we only want to only want to mask. So we'll use our and operator. The mask needs to be... Oh, actually, hold on. Am I an idiot? The mask is just whatever bits we want set to 1. I'm an idiot, aren't I? Yeah. Yes, which is what you just said. So basically our mask is this, right? What I wrote there, that's our mask. Okay, that makes it that makes this exercise way less tedious. Because I was gonna go through and just like hand figure it out. So that's F, like you said. So this would be 0x, or call it that, which is 15 is our mask. And then I think that's all we needed to answer there. And then for this one, we are going to mask Wait, yes, that's our mask here. Excuse me. So our mask is going to be this guy. Which is equal to this in decimal. But we also have to shift, right? So that's the part we need to do first, or next, I guess. So if we want to shift 8 bits, we actually don't want to shift. No, yeah, we want to shift 8. Yeah, that's right. Shift 8 bits. And then our mask is this. This is 240 in decimal. Can't count. $240. And then the mask here is the same thing up here. And we just want the lowest 8 bits, so we just need to mask. Cool. And what's that number in binary? Or what's that number in decimal? $255. 255. That makes sense, yeah, because it's all 8 bits are set. All right, I think we have what we need, and now we need to actually get the instruction. So let's go ahead and delete that. And so how do we read out 2 bytes at a time? I know I need to always increment the pointer by 2. So chip memory is always going to be incremented by 2. I know that. I also know I need to loop. And I don't know what I want to do for a loop though yet. I'm not liking this music. Yeah, it's clicking, I think. I think we're moving. The nice thing is, once we get this working, we can then start implementing some operations that will actually let us do something. And then hopefully we can get to a point where we can at least, my first milestone is going to be to draw the IBM logo. I've read that's a pretty, if you can get that happening, you're basically like well on your way to getting to the final solution. So if we can get that IBM test file to actually display, that IBM logo to actually display, then probably can get to the end of this project. I prefer size of loops, but you do you. Yeah, so I guess we need to iterate over the memory, but we need to start at wherever our program starts, which is at this constant that we declared up here. Did I kill the music? What did I do? Music, come back. Come back to us, music. Um, I don't know. I don't know. I bit flipped the music. On, off, on, off. I guess let's just get the first one out. I mean, because I'm not really sure what I need to loop over. I mean, I guess there's a certain rate at which we need to process the instructions. Right? There's a certain So this says subtract, so this is at a rate of 60 hertz. Let's just search for a rate. That's rate of 60 hertz. CHIP-8 also has two special purpose 8-bit registers for the delay and sound timers. When the registers are non-zero, they are automatically decremented at a rate of 60. Okay, that's the same thing. So I guess at what speed should I be running over our memory, or how often should I be checking our memory is probably what we need to loop at. But let's just see if we can get the first opcode. Let's just do that. That'll be a good first step. If we can parse out the first opcode, then it's just you know, do it more times type of thing, right? This is me reassuring myself. Okay. So every opcode is going to be uint 16 t. So we'll say this is our opcode. And I guess the simplest thing would be is we could just say chip memory at program start. However, that's just going to be the first byte, and we need the next byte over. So could we just do... I think we need to bit shift here too, right? Because we basically want to take the first byte, put it on the left, take the other byte, and then we have our 16. We have our 2 byte. David Bailey, hey Stephen, what's a CHIP-8? So CHIP-8 is basically a way to write programs for an old computer architecture. So basically what we're doing is we're building essentially an I think I'm almost thinking of that as an interpreter for CHIP-8 programs. But basically our emulator will be able to parse these old instructions for this, you know, long extinct or long obsolete computer architecture, and we'll be able to parse those programs and run them as if they are that program is actually running on that old hardware. If you look up CHIP-8, it's basically just an outdated set of it's basically an outdated programming language essentially for building programs for that particular architecture. And it has some very specific, you know, this is the way a program looks. These are the fonts you use. This is what a keyboard would look like, right? So you kind of have this specification that you're programming against to build an emulator or to build an interpreter that can work with those CHIP-8 instructions. I didn't know anything about it until 2 days ago when I was searching for good beginner C programs, and I ended up here, essentially. Yeah, it is super interesting. It's forcing me to it's forcing me to basically get comfortable with what did I say? It's forcing me to get comfortable with dealing with binary or parsing a binary file and moving through an array of binary values. I probably won't write anything for the emulator to evaluate. There are existing programs, like I have a test file that displays the IBM logo, and there's existing things that people like games that people have written in it. Like I think there's a Space Invaders one. So we'll probably just load up some of those existing programs and see if they work once we get to a working example, basically. So I think yeah, it'll be pretty cool once we get to a visual representation. It's not very exciting right now because we're kind of stepping through the motions of putting together sort of the nitty-gritty details. But once we get the opcode parsed and we can loop over it, we can then implement some opcodes to help us do some display, I think. And then we have to figure out how to actually make a display. I've heard people say Raylib is a good library for doing graphics stuff in C. So we might take a look at that. I've never done anything like this. So we shifted 8. So let's say we have these two numbers, or let's say these are our 2 bytes, right? So what we want to do is, let's say this is byte 1. Let's say this is byte 2. And I'm just going to throw some arbitrary values in here. And we'll say the second byte looks like this. Right? So what we're basically doing is the first step is, okay, read in the first byte and then shift, right? So we're going to result with this is what we're going to have in memory after we do this operation. And these should all be 0. Then we're going to read in our second byte. And we need to combine, which would be an OR, right? Because OR allows us to say, is 0 or 1 set? Okay, then we make it 1, right? So basically what we're doing here is, see if I can make this more understandable. What we're doing here is we're saying, let's combine these bits with these bits, right? And so then the result would be, if we combined them, 1, 1, 1, 0, 0, 1, 1, 0, right? And then the final thing we get in memory, which is our 16-bit int, would then be basically what we want, which is this guy. Which then we'll take this result and we'll put it through our logic down here to get the individual variables. So how do I get the next thing? I guess this would just be chip memory. Actually, I'm gonna do this. This looks really weird. I don't know if this is the right way to do this in C, but I'm just gonna say, since we're gonna move the memory pointer around, I'm just gonna do that. And then we need to advance this by 1. Oh, you've used Raylib? Kale, so how was the experience in Raylib? Is it hard to learn? Is it hard to work with? I'm very to be completely honest, I'm very intimidated by most of this stuff because it's just so outside my comfort zone. So I'm trying not to make a complete ass out of myself trying to figure it out. Okay, then the next step after this, which we don't have yet, is we'd want to take chip memory, and we'd want to increment it to move to the next thing. So now that we have our opcode, let's go ahead and print that. So let's do print line current opcode. And this is opcode. No, it's not hard to learn, but also is as it was my first lang and first lib to do graphics. That's fair, yeah. So maybe it'll be a little bit more foreign to me. Hopefully, though, if I get stuck, hopefully there's like a tutorial or something I can follow online that'll help me get unstuck. So far, I haven't gotten stuck. Gunheist, it is so comfortable that C# will feel like heaven. C# already does feel like heaven. But if I could do it as my first graphics lib, I'd say yeah, it's easy for you. Okay, I'm gonna try. I don't know if I think you're underestimating your own abilities and overestimating mine. Okay, so let's go ahead and do our operation down here. So let's call this uint16t. And this is what we're going to call in. We need to do our uint16t, which is in, or our nibble. What a silly word. And we need to and that by our mass, which is 15. And then we do uint16t. This is our x. And that is going to be our opcode by our mask of 3840. Getting close here. And then uint16t is our Y register value, which is opcode anded by 240. Oh, this is where we have to shift. I forgot to shift. So this would be shift 8 bits. Shift right 8 bits, and then and it. Like that. And this one is shifting 4 bits. Like this. And then you are gonna shift by 255. Or no shift, just anding. Just masking by 255. And that shouldn't be Y, that should be KK. I don't know why these variables are what they're named. That's just I'm just basically just copying and pasting this right here. So I'll just refer to him as that until I have a better name for him. If I come up with a better name, I'll rename him. Steven telling the bits what to do. I am telling the bits what to do this morning. Kale's been helping me quite a bit though. He's been fact checking me several times. He's much faster on the conversions between the different bases. So Kale's like my built-in number base converter. You know what is awesome, Steven? That within unsafe block in C# you can do all this stuff that you're doing now. Oh, okay. So I've never written any unsafe code in C#. Well, I've never written any unsafe code in C#.
And we just become best friends.
Vagme, thank you for the sub. I appreciate that. but I know that you can, and I've seen other people do it in their code before. But so this hopefully maybe will make more sense now in the future, now that I've come down to the lower level code. I think this experience will make me better. I think this experience, one of going through boot.dev, and I think being exposed to the C programming language, I think it'll all make me a better engineer, a better programmer in the long run. All right, I think we have everything we need. So let's just jump down to the bottom and let's just print out the instruction. And then we'll compare it to some examples. Yeah, so let's do print the current opcode. Let's print, this is gonna be in. In. So we have 4, do we have 4 variables? I thought we had 5 variables. Am I? 1, 2, 3, 4, 5, yeah. So am I missing one? 1, 2, 3, no, I'm not. I just can't count. Hey, what's up, Buzztronics? Good to see you. Oh my God, it's C. We are doing C stuff, yep. And this is it is sort of part of boot.dev. You learn C as part of the boot.dev path, but building the emulator is what I'm doing for my first portfolio project. I didn't want to do, it seems like a lot of other people who do that first portfolio project, they just use Python. And I know Python well. I feel comfortable using it to do things. So didn't seem like a good challenge for me individually. So I decided to do my portfolio project in C because I thought that would be more challenging. And when I was Googling online what would make for a good C or like a good first noob C project, this came up. And I thought, well, that sounds interesting. I've never done anything like that. So let me give it a shot. And that's how we find ourselves here today. Boot.dev requires you to have a portfolio. I don't think they require it. It's just part of their, like, what do you call it? Part of their curriculum. That's the word I was looking for. Part of their curriculum. So if you follow their backend developer path, which is basically just an organized list of courses that you should follow in a sequential order, they have like these milestones where, okay, you finish this course, now you need to build a personal project, right? And they do it, I think, once more. Yeah, right here, you have to build a capstone project. So it's not required that you have a portfolio to do the courses or the lessons. It's just a part of completing their path. You have to build a project, which I think is good. You know, I mean, that's where you learn the most, is by actually building stuff. Oh my goodness, I forgot that I have a key map in my NeoVim config that basically says if I'm in normal mode or I'm in insert mode and I spam KK, it exits to it basically escapes insert mode. And so every time I try to type KK, it exits insert mode. That's in. This is in. X, Y, KK. What do you have your caps locks bound to? So I have my caps lock actually remapped to, or I have my escape key actually remapped to caps lock. And I use Power Toys to do that. And if you don't know what Power Toys is, that Power Toys sounds like something you shouldn't be talking about on the internet, but uh, Power Toys is just like a set of Windows utilities that makes your life way better if you're a Windows user. I'm sure at some point it's going to get baked into the OS, but it hasn't yet. And they have a tool at the system level. I think it's under Keyboard Manager, where you can. Is it Keyboard Manager? Maybe not. Maybe it's something else. System tools. I made a video about it. Now I can't remember where I did it. Nope. Remap a key. There we go. Yeah, here we go. So I have caps lock map to escape. And it works pretty good. QMK is the best if you have it. QMK, what is that? Is that a tool for remapping? I like to compile and get stupid errors at compile time. That basically sums up my experience so far writing C. I think I don't like to program in dynamic language. Yeah, I'm not. The only exception to that is TypeScript. I really do like working in TypeScript myself. But which I guess some people would argue TypeScript isn't a dynamic language, but I would argue it still is because at runtime the types don't apply. But yeah, working in like raw JavaScript or working in Python, not super great experiences in my opinion. QMK is like AHK for Linux. Okay, interesting. Well, I'm not on a Linux box. I've never heard of QMK, but the Power Toys solution works pretty well for me. Do you share your NeoVim config on GitHub? Yeah, I do. Yeah, here, I'll put it in chat for everybody. There you go. All right, let's see if we can get this first instruction, yeah? Let's see, array subscript is not an integer. Array subscript is not an integer, but it's, I thought, what did I think? I thought that was valid because this is just pointing to the start. Am I making that up? Oh, it's not memory. It shouldn't be memory. Sorry. I know what I did wrong. So in the specification, we have we're supposed to store the current. We're supposed to, okay, so CHIP-8 has 16 general purpose 8-bit registers, usually referred to as VX. And then we have VF, register should not be used by any program. 2 8-bit registers. Okay, pseudo registers, which are accessible from the program counter. That's what it is. So we need a program counter, which is a 16-bit int. So let's go up to our struct and let's add that. So uint 16t. So this is going to be our, I guess we'll call it we can call it PC, program counter, like they did. Which means when we read when we read this in, we need to set the chip. We need to set the chip program counter equal to the program start. Like that. This is chip is a pointer, right? Yeah, so we're dereferencing, we're getting the PC member. So then down here, what we'd actually do is we'd say chip PC, and this would be chip program counter. Program counter. There we go. So is this correct? I don't know if it's correct, but I guess we can look and see what we would expect in the spec for different examples. So I guess this would be a sys address is what we have here. I think that's what we have. Multiple K, K, and J, and L, L, L for just escape? Yes. Yeah, I try to avoid the escape reach. It takes a long time. Once you develop that habit, it takes a long time to break it. Buzztronics. Oh, you're looking for PC or sometimes called IP. What is the type of chip? Oh, yes, we figured that out. But you obviously clocked that before I did, Buzztronics. SK Vlog, what the hell is this? This is basically, what we're basically building is an interpreter for a set of instructions that are that's designed to run on a long obsolete chip or architecture. So our code is basically acting like an emulator, and we're going to basically parse this binary file. We're going to read the instructions, and then we're going to have our program actually do what those instructions are supposed to do. And so at the end of the day, we should be able to take these CHIP-8 programs and actually run them through our code and get some sort of output, which hopefully we'll be able to display on a screen. That's the goal. I don't typically move a lot with NJ, and that is just because I am bad at Vim. I am bad at Vim motions, and I need to get better. But yeah, I always forget to do that, to do like 10J or 10K. I have relative line numbers so that I can do that. I just always forget to do it. Need to be better. Need to be better. All right, what's next? Let's update our to-dos. Let's give ourselves a little bit of dopamine. I think we have successfully done this. Parse individual instructions from binary CHIP-8. I think we've done this. Now we need to let's just say we're going to print all instructions from CHIP-8 file. I mean, I think that's just a loop, right? That's all that is a loop over all this stuff. But I don't know how I should be looping or when I should be looping. I always use numbers, even if it's 3000. So let me ask you this. For those of you who use Vim, this is one pain point I currently have with the way I navigate my code that I'd like to get better at. If I'm on line 96, right? And let's say I have to jump to the top of the file for some reason, or let's say I have to jump to the bottom of the file. I need to look at a particular thing down here. How do I get back to line 96. Obviously, I can go to 96, right? Can't I? Or I guess I can do a command to get there, but I have to remember what line I was on before I jump. Is there a way natively in Vim that you can just jump down and then, or jump up or jump down and then get back to where you were? Oh. So if I'm here and I do G and I do oh. Nope, that don't work. Loot of overhead, number just stopped my brain. Control G to specific line. But is there any way to do it without having to always remember to make sure you pay attention to what line number you're on? Control O will do the work. Okay. Ah, bro, that's great. That's great. So if I'm here and I do Control O, Control O. So does that just go back to where you're... So how do you... What's the inverse of that? Oh, that's a good one. Back to the line and buffer where you jumped from. Okay, Control O. So if I'm... Let's say I'm here... And let's say I just arbitrarily go to 100. If I do Control O, Control I, Control O, Control I, Control O, Control I. Oh, okay. I think I can put that to use. That's so much better than what I've been doing, because I've literally just been scrolling the file to get back and forth. Jumps. Ooh, that's nice. Can you do anything with that? So you can nav up and down and select with fuzzy find. Whenever I type a command, it just exits it. Why is it? Press enter or type command to continue. Have I broken it? Well, you guys just made my morning. I mean, I'm happy. We can just wrap the stream. The fact that I now know about Control O and Control I, it's good. We can call it a day. I mostly use Control O, Control I, Control U, and Control D for navigating. So Control U and Control D are for page, right? That scrolls a page. Wait until you find out about JHJK. What? What is GHJK? What? I don't understand that. Is that a joke? Are you guys playing with me? Then you'll end stream for real, for real? Sorry, I meant ZZ, not OO. What's ZZ? Is ZZ just last? I think ZZ is a little harder to type, honestly. Center this line. Center this line centers it, right? Centers, yeah. I use that one a lot. That was one that Butterscotch taught me. I had this guy that would hang out in my streams for quite a while over the past year. His username's Butterscotch, and he was always teaching me better Vim stuff. And that was a game changer. So ZZ, we've got Control O. Control I, Control O, Control I, Control O, Control I. Yeah, that's a good. I think I like that one. Although I think I could probably maybe come up with what's a leader I? Leader O. No, that's probably good enough. Control I, Control O. Paid attention too much to how he gets around. I mean, I've obviously watched a ton of his content. I've just never analyzed his key bindings very closely. All right, what were we doing? We're trying to figure out how to loop. So what should our CHIP-8 emulator... What should our chip emulator run at? What's the rate it should run at? This says CHIP-8 typically runs at 500 to 700 hertz. I guess what we need is some sort of loop that just runs forever, obviously. And we just need to decide how fast. I don't know. How many cycles each instruction takes? I don't know. The system timer is 60 hertz. Okay. So how do we set up a timer in C? C. How to set up... I just Googled it. Nice. Okay. So let's just start there then. I'm fine with starting with some... I mean, we've got to do something. We can't just stare at the screen and hope it works. So, well, the specification said something about hertz too, now that you say that. So it says, what does it say? So it has timers. Okay, so CHIP-8 has 16... No, here we go. CHIP-8 also has 2 special purpose 8-bit registers for the delay and sound timers. When these registers are non-zero, they are automatically decremented at a rate of 60 hertz. See the section. So I think that kind of tells us, right, the rate at which this is going to run. It's going to run at 60 hertz. And then if the chip... Yeah, so if the chip is supposed to run at 500, or let's make the math easy. If the chip is supposed to run at 600 hertz, that means for every one, I I don't know what you call it. Let's say for every one cycle of our emulator, the chip, we should process 10 instructions, roughly, is the math I'm doing. So I need to figure out how the heck to orchestrate a 60 hertz timer is what I need to do. Does that make sense? Does that make sense? Yeah, it needs to be decoupled from the for loop. Exactly. So basically what I'm thinking is we need something like this. We need, let's put this up here. So basically we need something like while, right? And then inside the while we'll have a for where we will do, let me comment that out. So our regular cycle for the emulator is 60 hertz. But within each cycle, we will process 10 instructions, making the chip run at 600 hertz. I.e. something like this. Is I think what we can also remove this to do. So we already did that. So I think this is what we're looking at, something like this. Hey Steven, hope you're doing well. Just checking in to see how you're doing. I'm doing good, I am Trapped. Thanks for stopping by the stream. It's always nice of you to do that. Life is good. Yeah, no complaints. I've been working on a little side project, which is a little Tory application. Tari application. I never know how to say that word. And my son starts football season next week, so I'm excited for that. I'm excited for football to be back in our lives. What else? Work's going the same. Work's always been. I'm so blessed to have a pretty great job. You know, it could be so much worse. So I've got food in the pantry. I've got hot running water. You know, life is good. I've got very little to complain about. The only thing I'm complaining about right now is I need to figure out how to do, like what Kale just said in chat, I need to do 60 ticks per second, right? Let's see. When emulating a real hardware like Game Boy or Game Boy Advance, you would count how many cycles each instruction took. And when the number of instructions you've executed so far is the same as 1/60th, you render your frame and wait for VSync. Interesting. I think that's all. I don't know why I added you. No worries. I think, so some of that's above my head. But I think what I need is first thing is I need 2 timers, right? I need 2 timers. I need a delay timer and a sound timer. The delay timer is active whenever the delay register is non-zero. This timer does nothing more than subtract 1 from the value of DT at a rate of 60 hertz. When DT reaches 0, it deactivates. The sound timer is active whenever the sound timer register is non-zero. This timer also decrements at a rate of 60 hertz. However, as long as ST's value is greater than 0, the CHIP-8 buzzer will sound. When ST reaches 0, the sound timer deactivates. Okay. So let's just go ahead and add those fields to our struct, and then we can start talking about how we manipulate them. So they are, what are they? They're 8-bit. I think he said 8-bit. Yes, 8-bit. So we have uint t. And what did they call theirs? They called them DT and ST, I think. I got to figure out how to navigate this spec better. I'm just scrolling up and down. Okay, DT, which is our delay timer, DT, and then we also have uint 8T, which is our sound timer. I really don't think I need to do anything with the sound timer quite yet. But I'm not sure. Let's say you have a loop that iterates each 1 second per 60. You subtract from the timers each iteration. The question is how many instructions you have to execute each iteration. So yeah, so that's where I know I'm going to execute 10. So like I know my inner loop is going to look like this. It's going to say for int I equals 0, I is less than 10, I plus plus. And then we'll inside here we'll say parse and execute instructions. It's the outside. I'm not sure how to set up this default 60 hertz thing. 10 was just arbitrary. I looked up. They said that CHIP-8s usually run between 500 and 700 hertz. So I was just like, okay, roughly we'll do 10. How to set up for CHIP-8. You can use VSync if your monitor's refresh rate is 60. What is VSync, Buzztronic? I know nothing about these magical powers you talk about. Is that something from like a library? Yeah, the whole graphic side of this is all, or I guess game side of this is all foreign to me. So what VSync does is when you tell the GPU to draw your frame, it waits until the monitor refreshes. So your process pauses until the frame is drawn. Interesting. Interesting. Okay, so how about we define some more constants? Yeah? I think that's a good place to start. So let's do define. Though for a lot of games, I like to turn off VSync. Aren't you going to emulate the display? We are, but we don't have any. We haven't even got that far yet. I haven't figured out how to actually. I don't know how to actually draw things to the screen and see. So that's a whole separate. That's a whole separate adventure. So this would be this is gonna be our CPU. I'm gonna call it our CPU clock hertz, and we're gonna set that to 600. And then we'll also define Let's see, uint target frame time is 16. 1000 equals. Also, Steven, you sound different. I did get a new mic, so maybe that's why I sound different. Nice to see you, Artwork Studios. Hey, what's up, Imjurta? Nice to see you. It's been a while. Hey, man, quick question. Do you think you would learn a language better while doing it in work instead of doing it as a hobby? I want to continue learning Java and C#, but I'm not doing it at work. So I don't necessarily think you... I don't necessarily... Okay, this is an interesting thing for me to talk about, actually, because I kind of am in a similar situation where at work, I mainly write a lot of TypeScript, a little bit of C#, but a lot of TypeScript. And outside of work, I work in those languages as well, but the percentage is skewed a lot more. Like I work in C# and other languages far more than I work in TypeScript outside of work. So I have two thoughts about this. One is I don't think it actually really matters. Like if you want to be good at a particular language, you don't necessarily have to be employed in that language. You know, like you see lots of examples of this, like people who are really influential and huge open source contributors in particular stacks don't necessarily do that stack for their day job, right? So there's proof that it's possible. I do think, though, you have to be honest with yourself. If you want to be really good at Java, but you're only spending 2 hours a week, right, writing it because you have a day job and a family and that's all the time you can allocate for it, and you compare yourself to somebody else who's spending 40 hours a week at their job, right, writing it, it's like, it's kind of hard to argue with that. Like that person's putting in more reps, right? And theoretically, more reps is going to lead to, greater gains, albeit with some amount of a diminishing return. The other, I think, piece of the puzzle is the types of problems that you solve a lot of times dictate, right, what gains you get from your reps, right? It's kind of like the same thing in the gym where, you could do 10 sets at 225, or you could do 10, let's say you do 10 sets of 3 at 225 or 10 sets of 3 at 315. One of those has a greater magnitude of effect. And I think when you're at work, you probably have a higher likelihood of being presented with a more diverse problem set. So you get more opportunities to solve more problems of different kinds and probably of different difficulty levels. Whereas in your own off time, you sort of have to seek out those problems. You just have to contrive or come up with those problems. So basically, my answer to your question, Imjurdo, is basically, I don't think it's necessary, but it could potentially very much help, right? So it's like, would it be better to learn a language if you were working in it? It would probably help, but I don't think it's necessary. See, Artwork Studios, have a good day, man. Let's see, but you're using 16-bit int, const uint, target frame 16, instructions per frame 10. By the way, you can type def U8, U16, U32, so you don't have to type the longer version if that bothers you. Oh, nice. That's cool. Yeah, I did not know that. It doesn't bother me to type the longer type def, but I did not know you could shorten it. That's nice. I'll have to remember that. Okay, then we'll do timer hertz, which is going to be 60. I'm just going to try to get this working, and if it's not right, we'll fix it. So this is going to be cycles per what? Cycles per frame, which is going to be equal to our CPU clock in hertz divided by our timer. That's where I'm going to start. It is the same how you shorten struct CHIP-8 to just CHIP-8. Nice, 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 nice. Okay, I'm going to come down here. I'm going to uncomment this line. And this is going to be less than... Oh, I could have practiced my Vim foo. Hold on. Let me practice my Vim foo. That's on line 8. So we're here. Control O. Control O. Control I. Control I. God, I don't like this song. Too loud. Make sure you cast one of those variables to float, otherwise you'll get back an int. Okay, well, all that, okay. The accuracy of all this, I'm not worried about right now. So we'll address those edges here in a minute. I just really want to get to the point where we're actually processing instructions in a loop. But I hear you. I'll even add a to do. Buzztronics says, do your division. Do non-int division. See, I don't know how to I don't know what the best way is to get back to that function. Or that for loop from here, because I don't know what line it's on. I guess I need to pay attention to the line numbers better or something. Otherwise, I just spend all my time vertically scrolling. Oh, cycle per frame is an integer, so it doesn't matter. Oh, yeah. It does not matter. They are both ints. There we go. I did it. Control O, I did it. Control I, Control O. Control I, Control O. Slowly but surely, I will get better. And then I'm just going to make this, I guess, a while loop. And we'll just run forever. And in C, how do you do a forever loop? Forever, I think it's just while one, right? Forever while loop. While one. While one, yep. But now we need to actually print line processing instruction. Now we actually have to do something to the timer. Let's see, I use vsplit for that use case. I keep my cursor at its position in the current split and do whatever quick change in the new split. That's a good idea. That's a great idea. I like it. See, Buzztronics, have fun coding, man. Thanks for all your help. That's very much appreciated. I hope you never feel like your help is not being received, because your help is very helpful. the student is the problem. Sometimes I just don't know enough to I don't know enough to execute on the help that I'm being given. So, you're it's very appreciated. Please don't give up on me. I will get better. Okay, and then the spec says we need to decrement this at what? Oh, what do we need to decrement this at? Timers. The delay timer is active from the delay timer register whenever the delay timer register is non-zero. This timer does nothing more than subtract 1 from the value of dt at a rate of 60 hertz. When dt reaches 0, it deactivates. So we basically decrement until 0. Until 0. And we need to initialize to 0 too. So where do we do that? We should probably isolate this initialization logic in one place, but so we'll just set this initially to this will be our sound timer and our chip DT. We'll set both of those to 0 because I believe, if I'm not mistaken, there is a instruction that fucks with the delay timer. Yeah. So there are instructions that will actually change the value of that timer. So we'll start it at 0, and then we'll do the processing like they said. Let's see. Include. Oh, there's a timer? That's cool. In C, they have a clock. Where'd you find that? T.time.h? That's pretty cool. This function returns the processor time consumed by a program. And what methods did you use? Get ticks. Time spec, clock, get time. Time spec, time.h. Let's see. That's pretty cool. Man, there's so much about C I don't know. All right, I'm not going to go down that path yet. I think I'm going to stick with what I'm doing. But it's nice to know I have that in my pocket if I need it. Okay, so if our chip dt is greater than 0, we're going to do something. And then also if our chip st is greater than something, we're going to do something. Let's see, I use Chrono in C++, haven't done this in C before. You and me, bro, both. You and me both. But we're gonna try to make it happen. So this is where we need to, if we're greater than 0, we're gonna decrement it. And we're gonna do the same thing here. Now, I think if I scroll back in chat, Kale, you were already talking about the wait, because we need to wait some amount of time. Oh, the other things we need to do here is we don't have, well, I don't know how to do it yet, but to do play sound. Else play sound. I'm gonna put some coffee on real quick. Oh, I didn't start my coffee timer. Or my coffee cam. One second. All right, the water is currently boiling. So while I wait for the water to boil, let's see if we can finish this train of thought we have here. So our train of thought is what Kale was talking about earlier is we need to maintain the 60 frames per second, right? So on each iteration, we basically need to figure out, we need to know when it started. And when we get to the bottom, we also need to know when it ended, right? And then we need to calculate if we're below our target, then we need to sleep for a certain amount of time, right? So what's the diff? Our target is, what did you say it was? You did the math for me, Kale, didn't you? You did, yeah, 16.66. So 16.66 milliseconds. Thank you, Kale. And then we need to basically say, okay, if the diff is, so if diff is less than, no. Yes. Yes, if diff is less than 16, I guess we're not addressing the fact that it's over, but this is not supposed to be perfect, okay? We're not building, we're learning, we're not. Perfection is the enemy of good. So diff is less than 16, then we'll sleep. Then sleep. Yeah. How do we get the timestamp? So this might be where Kale's recommendation for the time library comes into play. I've actually really been liking my DuckDuckGo Google search, or my... I've really been liking using DuckDuckGo for my search engine. Let's see. How to get timestamp in C in milliseconds. Timestamps in C. Lloyd Rochester. What do you say here? Converting to epochs in milliseconds. I use DuckDuckGo through Heimdall. What's Heimdall? Heimdall. Ooh, application dashboard? What's this? Oh, that's pretty. What is this? Heimdall application dashboard. Heimdall application dashboard is a dashboard for all your web applications. It doesn't need to be limited to applications, though. You can add links, anything you like. There are no iframes here, no apps within apps, no abstraction of APIs. If you think something should work a certain way, it probably does. How have I not known about this? Self-hosted intranet. This is cool. So what's your address for your self-hosted homepage, Kale? Like, so I could do something like homepage.freeborn.cloud or something. That's cool. Where's the docs? Are there docs anywhere? There's the install instructions. I tell you what, I learn about the coolest things when I stream from you guys. I think the coffee's done. I'll star this. I'll come back to this. I like this idea, though. Star. Okay, then we'll figure out how to do... We'll figure out how to do timestamps and see. But first, coffee. Yeah? Coffee. Bring on the coffee. I'll be right back. Yes, FE911s, we have our coffee cam. Like that? It is the coffee cam 2.0. I would still like to have a better setup. It's not quite what I want, but it's working for now. It is working for now. One of these days I'll... Where's our... There it is. How to get a timestamp. Get timestamp in milliseconds. So get time of day. So what does this function return? Get time of day in C. Also, thank you for being a member. I think I said thank you to Kale already this morning, but thank you, FE911s. Thank you again, Kale. Just thank all my members. I appreciate you guys. It's very kind of you guys to support my channel that way. C for dummies. Sounds like my kind of speed. Okay, the get time of day is defined in sys_time.h. Like many get functions, it has a companion set time of day. The get time of day function fills two structures with details, you guessed it, the current time of day. The time eval structure contains two members. Time t is a variable of TV seconds. The first TV seconds is a time t value, the number of seconds elapsed since 1970. The second value is a microsecond value, which the computer knows but isn't included with time t value. Okay. So it looks like we're going to have to bring in the time.h header, right? At the very least. So include time.h like this. And then we should probably have a function. I don't know what it's return. Well, I guess it'll just return along, right? And that should be get time. And for now, I guess let's just return 0. But what it should do is it should get, it's a struct that it gets, right? I'm going to put this over to the side here. Oh, so you have to actually declare these, huh? So you have to have struct time val TV and struct time zone TZ. Well, I guess actually we don't need that one, so we can just do get time of day, pass in TV, pass in null. And then TV, once TV is filled, it has a member called TV, so I'm going to do long milliseconds, and this is TV.TV seconds divided by, there's 1,000 milliseconds per second, so I'm just going to make a constant here, constant ms per second. It's 1,000 ms per second. Had to take a domestic flight because it was cheaper and faster than train. Nice. Where do you live at? 199? Train travel here in the United States is very rare. Most people, have I traveled on a train? I think I've traveled on a train maybe once in my life, but it's not something I think that's very common for people to do here in the States. Oh, you're in UK. Okay, maybe that's more of a thing. I mean, honestly, traveling by train should be more of a thing. It's just I don't think we have very good infrastructure for it. I forgot to add to use local DNS. That'd be separate to Heimdall. Otherwise, you just access it from the IP of your Docker machine and port. You could point Nginx proxy to it easily. Yeah, I think that's what I would like to do. So, is this a dashboard that you would want to be publicly available, Kale, or is this a dashboard you would not want to be publicly available? Or can you make it publicly available, but require authentication or authorization to it? Oh, it's okay. It's password protected. Okay, cool. Yeah, so that would be awesome to have. Can you set up dashboards per user then? So like, could my wife have a dashboard and then my sons have a dashboard and I have a dashboard? I know I could probably read the docs, but I have an expert here. Yeah. Okay, cool. That's awesome. I'm gonna set that up tonight probably. You said yes, yes, and yes. Okay, I'm gonna set that up. That's very cool. Yeah, shoot me over any examples you got. I would love to see it. Yeah, I love that idea. I'm gonna go get my coffee real quick. I'll be right back. Okay. Okay. I'm back. The only annoying thing about Linux is that when it comes to some of my day-to-day work-related advancements, it doesn't exist. Shit barely runs on Windows anyway. What do you mean? Hold on, let me read that again. I don't think I totally got it. Kale, thanks for sending the compose too. It comes to some of my day-to-day work-related advancements. What do you mean 199? I don't think I understood. I don't think I understand your frustration. Oh, work-related software. Okay. Now I understand your Now I understand your frustration. Yeah. Until Linux enters kind of the mainstream on the desktop, right? There won't be a priority to make it work well on Linux. Yeah. That's the state of the union. That's the state of the union. Okay. Back at it. So now we can do our diff, yeah? We need to do some refactoring too. This function's doing a lot of work. Let's see when it started. So this would be frame start. So this would be a long frame start equals get time, and then we'll have another one down here called frame end, and we'll calculate the diff, which is going to be frame end minus frame start. And if, let's see, what should I call this? Like target. This is also a float, right? Too. So we do target diff equals 16.6. Or actually, this is actually more like the min diff based on how we're using it, right? So if diff is less than the min diff, we need to sleep. Okay, back to the documentation, because I don't know how to sleep in C. It's funny, you realize that, like, you know, in every language, you just become this noob all over again, you know? Because like I don't know how to do this. I don't know how to do that. Let's see, sleep in C. Guess what the name of the function is that you use to sleep? Sleep. Oh, it's different based on what platform you're on. So if you're on Linux, you have to bring in UNI standard.h, but on Windows, you bring in a different one? Interesting, okay. So how would you do that if you wanted to support both? Cross-platform. I don't even know if I need to worry about this, but cross-platform sleep in C. I sent examples in Discord, but not trying to dox shells as well. No worries, dude. No worries. Thank you for sending all that stuff. That'll definitely be my little pet project tonight after work while I'm kicking around the house. I'll set one up for me, and then set one up for the boys and my wife. I just got them set up with email addresses too at our family domain. So the next thing I have to figure out for my self-hosting setup is, and you may already have this figured out, Kale, but I'd like to have a way to have like a Google Drive or even like a Google Suite alternative. You know, like Google Docs, Gmail, Google Calendar, all that stuff. I'd like to have an alternative to that that's self-hosted. Nextcloud, okay. How do you handle IMAP? So basically, for the email, I just send through a relay service. I use SMTP to go, and then I have Dovecot and what's the other one? Dovecot and yeah, I use Image for the photos already. I'll have to check out Nextcloud. I don't think I've ever looked at that. What? What's the name of the SMTP? God, I just set this all up the other day. It's really bothering me that I can't remember. Dovecot and postfix. That's what it is. Postfix. I don't know why that escaped me, but yeah. So I use postfix, Dovecot, and then I use SMTP to go as a relay service for sending. Nextcloud is like an MS Office replacement, and OneDrive and Calendar and stuff. Sweet. Is it difficult to set up? Have you worked with it before, Kale? Can I use you for IT support? You might be getting tagged in the Discord a whole lot more. It's not hard to set up. Okay, cool. Yeah, MS domain. That's good. That works. What was I trying to... Oh. Completely lost track of what I was doing. Cross-platform sleep function for C. This is somebody's gist. Oh, so you can do preprocessor directives to check to see what platform you're on. That's interesting. It's kind of interesting. Yeah. Yeah, I didn't know that. I'm learning all new things about C. I don't think I need to worry about cross-platform. I just want to get this working on my machine. This is a my machine program. That should be the name of my software company. My machine software. C has so much. That's wild. Yeah, it's actually wild. And it's so annoying to get it working cross-platform. Yeah, I guess that's the beauty of using one of those other languages, right? The higher level, the abstracted, something like C# that takes care of all that for you. Okay, so I think I'll just make it work then on Windows. So we have to do include windows.h. And then we come down here and we say sleep into sleep. And that sleep takes it in seconds. So I have to go from seconds to milliseconds. Oh no, in Windows systems, it takes the time as a number of milliseconds. So I can do whatever the difference is between our min diff and our actual diff, right? So we're basically just saying, hey, you're so many milliseconds short, so we need to arbitrarily tack on some time in the loop. All right. think that will... I think that's this dog will hunt, but I actually don't know. Should we run it? It's just going to be an endless loop, though. How do we... Will Control-C break... I actually don't know. This is all stuff I just don't know about using this language. Let's see, will Control-C break infinite running while loop in C? Okay. Signal SIGINT int hand stop. So I think your program should look something like this. So basically you set up a signal, you pass a specific signal and you give it like a callback, and then you check for that piece of state. And I guess volatile tells... this must tell the compiler something about this value so that it I don't know, it must volatile, you can do volatile I think in C# too. To tell the compiler not to fuck with your shit. So I'm guessing C does something similar. Yeah, but Control-C, obviously, yes. Like you said, Kim, the thing that I was kind of questioning was I have to explicitly wire up my program, though, to honor that, right? C won't just do it, will it? I'm guessing the answer is yes. Because everything in C has to be explicitly done. Sorry, I keep getting distracted by... looking at YouTube Studio. Yeah, okay, so we'll set it up like this, we'll set it up like this Stack Overflow post says. Where are you? So we'll create a global. Just gonna set it up here. So this will be volatile. Volatile. Sorry, I can't see chat. But yeah, you're right. You need signal.h. Okay, so let's bring in... I didn't want to run the program and then not be able to kill it. So we need signal.h. And then we need volatile. Hey, Danny, what's up, man? How are you doing? Thanks for stopping by the stream. Appreciate you. So sig atomic t. I don't know what that is. I'll do a little bit of reading on that. Keep running equals 1. This actually might change once we get to rendering the display. Maybe we'll do this differently, but this will work for now, I think. I kind of wonder if it shouldn't be on the chip itself. I guess it can't be because we have to void. So then we'll do void handle sig int. And we'll set to keep running equal to 0. And then we'll come down into our loop. And whenever we, or I guess our main function, and that's just one of the first things we'll do is we'll set up that signal. We'll say signal sig int. And we'll also register signal sig term. And then we'll do handle sig int. Is that the name of our function? Yeah. Where are we? You can kill it with kill in Linux on the PID. Yeah, I just figured this would be the better way to approach it for now until I figure out how to handle keyboard inputs and everything. I'm doing great. What are you building? Okay, so I'm doing boot.dev, obviously. I think you've been to a couple of my streams in the last couple of weeks. But I'm doing boot.dev, and I'm at the point in their curriculum where now I have to build a portfolio project. And so I picked I guess it's a very popular, like kind of beginner C project where you build what's essentially an emulator of a very old, now obsolete chip or computer architecture that ran programs that were written in this very specific instruction set called CHIP-8. And so what my code is going to do is it's basically going to be able to parse those CHIP-8 programs and then run them. And you can actually play like some games, I think, on the emulator. I think people have written like Space Invaders for it. And the thing we're trying to work to right now is we want to get to a point where we can just print something like an image, particularly the IBM logo, in a window. That's kind of the next big milestone we're going to try to get to. And then after that, we'll try to get to the point where we can actually load one of those games, the Space Invader game. I think there's Tetris can be played in it. So we'll see if we can get that far. We'll see. But that's what we're building. So we're handling the signals. And then instead of while 1, we'll change this to keep running like that. And I think that should take care of us. Just looking over the Stack Overflow code one more time, make sure I didn't. Yeah, volatile, your handler function. Oh, your handler function, I guess, needs a argument, which is going to be oh, I have that there. Let's try to run it. Let's see what happens. Yeah, I think it'll be a fun project. It's been a little bit of a struggle because there's 2 aspects of it that I'm not particularly good with. I don't know C, obviously, so I'm having to look every single thing I want to do up, basically, which is just kind of the learning process. And then it requires a lot of binary operations because you're dealing with a binary file, and I just don't know my bitwise operations very well, so we're going slowly. We're enjoying ourselves. We're exploring the things we don't know, taking the time to read the documentation. And I'm trying to avoid much AI use because this project has been built by a bunch of people. So I'm guessing if you asked an LLM to do this, they could one-shot it. So I'm trying to avoid AI at the moment as much as possible. Okay. Implicit declaration of function get time of day. Expected expression before equals token. Note an expansion of macro cycles per frame. Expected before. Yep, missed a semi. Invalid suffix. Yeah. I'm such a. Okay, those are some silly mistakes. Obviously, you can't add units to a number to a float. And then I missed a semi up here. Where were we? Where's the while loop? There it is. So I missed a semi here. I think you can try Nan to Tetris once you're done with boot dev. You will have fun learning low-level stuff and building your own computer. Okay, cool. Yeah, I'll have to add that to the list. I don't know how much time I'll spend in this area of programming. This has never really been a deep area of interest. I feel like it's going to make me a better programmer in the long run. But how much time I actually spend like seeking it out, we'll see. But I'll definitely keep that in the back of the mind in case I want to explore anything further. I'm enjoying this evening. This is my area of interest. Oh, awesome. Very cool. Yeah, then this would be a great project for you to work through. Yeah, embedded systems. Yeah, you'd be right at home in all this kind of stuff. Okay, I don't think I'm guessing define doesn't let you do a calculation like this. Hashtag define in C. Can you perform calculation? I'm guessing you can't. So you can define functions or constants. So that's not going to work. So I guess I'll just define a global then and just call it constant like this. And then try again. Okay. God, Python has absolutely ruined my ability to write a semicolon. Okay, get time of day and sleep. Did you mean sleep? Yes, I did, because sleep must be the right one from the window.h file. Okay, so sleep becomes sleep. Now, what about this get time of day? Am I not calling that right? That's what I thought about Python. Yeah, it's ruined me, man. It's freaking. I had such good semicolon habits, and then Python ruined them. Get time of day. Oh, sys time.h. I haven't written much Python lately because I always forget semicolons when I go back to C++. Dude, it is. It's a muscle memory thing. It's a muscle memory thing. Okay, argument 1, get struct time eval, incompatible type for argument. Note expected time struct. Oh, it's a pointer. So we need to use the address of operator. I think this compiler is pretty helpful. The error messages it spits out, it's pretty good, in my opinion. Okay, there we go. So we've got our infinite loop. And we just killed it. Fantastic. Now let's move our processing opcode logic inside the loop. Yeah? So let's actually move that up here. Let's put that there. We don't have a formatter. I just tried to auto format it. We'll do 3 tabs. We need to come back 1 tab. Okay. And now let's also run this again. Okay, so I see the same opcode over and over and over again, but the reason for that, right, is because I am not actually advancing it. So we have cycles per frame, we have I, and I should be advancing this. So let's try again. Did I write that out? Yep, that looks correct. I think it's working. It's working! I need the Anakin. Okay, I'm gonna write that down. I need like an Anakin clip that I can play whenever moments like this happen. I think it worked. I have format on right. Which compiler I'm using? So the compiler I'm using is this one, GCC. Is what I'm using. So, Kale, are you writing C and C++ in NeoVim? And if so, what are you using for your config? Because I don't have any LSP or anything set up right now. I guess I was debating on whether or not that was good for me to have LSP support in here. I see Mason has Clang D, I think is what everybody recommended. Yes, it's a very emotional moment. I like the emotional emote is the correct emote to use. Clang D. Okay, that's what I'll use then too. I haven't set it up though yet, so I'll do that later. I don't want to get distracted. So let's go ahead and give ourselves some dopamine because we did actually accomplish one of our to-do. So print all instructions from CHIP-8. Wonderful. This was the clip I was thinking of. Oh my god, why is that such terrible audio? That's how I feel whenever I that's how I feel whenever I make something actually happen. Playing D is the best LSP for C? Okay. I'll set that up then probably today. I was debating on whether I should be writing with an LSP or not, just given how new I am, but it probably wouldn't hurt. It probably would make some of the documentation a little bit easier to get to. Do you use -wall -w extra flags when you're compiling your code? I don't. Should I be? So this is how I'm I don't know anything about the compiler or any of the options that it has. So this is how I'm currently compiling it. I don't know if you can see that. Let me make it a little bigger for you. I'm just doing this right now. So what would you recommend I add here? You recommend I add wall and extra like that? What do those do? Let's see, GCC shows all warnings and errors. Okay. After O? Okay. So do W all and W extra like that. Let's see, W, GCC, W, all. Yeah, what does this do? Explain. This might be a good question. This might be a good AI question. Hey, what's up, Eric? Nice to see you. It's been a long time, man. Hope you're doing well. I have so many windows open, it's insane. I gotta clean up my browser tabs. Why do I have such a bad habit that I just open up way too many windows? Get rid of that. Put this one in here. Get rid of this. There we go. Okay, so what do they do? In GCC and Clang, wall and extra are two of the most important command line flags you can use when compiling C or C++ code. They tell the compiler to enable a broad set of warning messages to help you catch bugs, memory issues, and bad coding practices before you even run your program. Well, that's wonderful. Let's see, warning all. Despite the name, wall does not actually turn on every warning GCC has. Instead, it enables a comprehensive list of common, generally undisputed warnings about constructions that are likely to be bugs or questionable coding practices. Uninitialized variables, unused variables, missing return statements, suspicious conditions. Okay. Warning extra enables additional warning flags that are not covered by WWall. Signed versus unsigned comparisons, unused functions, missing field initializers, empty bodies. I love it, man. I just leveled up. Thank you, Kale. Thank you again, man. That's perfect. I want all the warnings. It has been a while. I hope you're doing well, Eric. It's nice to see you again. I appreciate you stopping by the stream and saying hi. It's very kind of you. Let's just try this for ourselves and see what happens. Ooh, there we go. We got one. Hey, success. Warning, unused parameter sig. So how do I resolve that? How would I resolve an unused warning like that? Why is my screen so much bigger? Oh, because I zoomed in to show you the code. Okay. Did you bought that keyboard already? The weird looking one? I haven't. I would love to buy a split keyboard, but I have not. They're just so dang expensive. I just spent a couple $100s on a new mic, and I spent a couple $100s on a new lens. I haven't got the new lens yet. So right now I'm kind of tapped on setup upgrade money because I've been saving for those for a little while. But I would love to get a split keyboard at some point. Upgrading the setup is all about triaging. You know, it's like I have several really nice mechanical keyboards that I absolutely love. So the need for another keyboard is much lower than a need for a better audio or better visual. What are we making? So we're doing a project. I'm trying to learn C, or I learned C while doing boot.dev. And now I'm at a point in boot.dev where you have to build your own project. And I wanted to build my project in C because I thought that would be more challenging and it would help me practice and get more exposure. So when I did a Google for like good beginner C programs, this project came up. And this project is essentially building an emulator of old hardware that people have written programs for that you can run if you basically build an emulator of that old hardware. So that's what we're implementing in code, is the ability to process these binary files, extract the instruction set, and basically simulate running those instructions on kind of a virtualized chip. And so far it's going decently well. I sent you the Lua config with wall for LSP and NeoVim. Just popped it in the Discord for later too. Awesome. Dude, you're so helpful. That's going to make it easy peasy to set up later. Address unused warnings in VCC. I mean, can I just omit this? Will it still, well, I don't know. Okay, so I can just omit it. Wonderful. So let's go ahead and run then. And there we go. There's all of our instructions. All right, I'm going to add some comments because eventually, so this sets up Control C handling. Let's see, validates file argument. Load file. A lot of this stuff we'll be able to extract into separate separate functions. Okay, this is our main loop. Gonna remove that. Main loop. I'm gonna leave these comments for now. We can pull those out at some point. Okay. So what do we need to do next? So we're at a point where we have a loop. We are getting our instructions. If we want to be able to render the IBM logo, we need to see what instructions we would need to do that. I don't actually know what instructions we need. Do you also work for some games with code? I don't. I've never really done much game programming or development or anything like that. This is the first I've done anything really with C, and it just so happened that it fell in the ballpark of being able to run a game on the emulation. Yeah, I don't know why game programming has never really piqued my interest. It's never really been my thing. Maybe that'll change as my kids get older. I think it would be fun to build a video game with them. They're into video games, and I like to play video games. That'd be a fun activity, I think. Eric, can I ask career and skill advice? Sure, man. Yeah, I'm happy. I mean, obviously, you take all my thoughts and opinions with kind of an n equals one type of magnitude because I'm speaking just kind of from my own personal experience. But I'm always happy to share my thoughts. So let's look at our instruction set to see what we would need to play a logo or draw a logo. So clear the display. Return. You know what? We can actually do this better. We can actually just print the opcodes. And we can just so let's do implement opcodes present in the IBM logo chip file. Right? So let's go ahead and convert. Let's just... Oh, this will be another good learning experience. So let's build up a list of all the opcodes, and then let's print them to let's write them to a file. So instead of having just a binary file, let's get a actual representation of what all the opcodes are in this program, and that way it's so it'll be a little bit more human readable, and then we can see which opcodes we're working with. I think what would be easiest to do is write this to a CSV, and then we can open it up in some sort of kind of table explorer, and that will help us better visualize what we need to do. So what I want to do is I want to build up a string. Create a string for each opcode that is comma separated. Then write that string into a .csv file. Write headers of variable name to .csv file. Okay, so how do I... So I guess a list of strings would be equal to a char star char star star type would be a list of strings. What game would you try to build in if you have to think about an entire new game? Well, it would be something that my kids would be interested in playing. My youngest son is really into first-person shooters. My oldest son, I think, has a bent... He plays... I mean, they all play everything, but my oldest son, I think, has more of a bent towards, like, RPG kind of level progression. Like, he's been playing a lot of Power World recently. So, obviously, I can't make games of that quality. But I think if we could like make maybe simpler versions of those, like a dungeon leveler might be cool, like a top-down dungeon type of game might be kind of cool. But yeah, having never built a game, I just don't know what I don't know. Like, I don't even know where I'd start with the art. Like, where would I get art? How difficult it is to create art. I'm not really an artist. So I'm guessing I'd have to go buy some game assets and whatnot. But yeah, maybe it's something for us to do in the future. How would you approach learning to code for job's sake if you were starting out? I currently work as delivery driver and am taking Python course since I want a real job, but kind of scared of AI. So I think it's awesome that you already have a job. That's awesome. It's great to be employed. It's great to have income. Now you can just worry about planning the next steps. The way I approached learning to code was I went through free code camp. So I think free code camp is just a great starting place because it really walks you through a structured curriculum. It has no cost, and they force you to do actual project-based learning where they basically give you a set of requirements and they have a set of tests to validate those requirements, and you have to implement against them. So it kind of simulates the real world in a lot of ways, in my opinion. I think if you really want to get proficient with Python or any programming language, the way you get proficient is by building projects. So whatever course you're doing now, I would finish it. That's awesome. But as soon as possible, I would start trying to build projects that actually solve problems, whether they be your problems or a family member's problem or a problem that you see at work that you think, hey, if we had some software, this would be easy peasy. Then I would start documenting those, making nice readmes, making nice repos, right? Putting them up on GitHub. Maybe you could build yourself your own little portfolio site or your own resume site. Then I would just start applying. I would encourage people to apply earlier than they think. Apply before you think you're ready, because you're never really going to think you're ready. So the key is, once you get your feet under you and you're building projects and you have stuff in your portfolio that you can speak to and talk about, start applying for jobs. Looking for a job and getting a job sucks. It's hard. I've never had the luck of being recruited. No one has ever sought me out and said, "Oh, please, Steven, come work for my company." I've always had to knock on doors and call people and follow up to get a job. I know a lot of people think there's some secret solution to it. I don't. I think it's persistence and enthusiasm. So don't get discouraged if you apply a ton and get rejected a ton. You just need one. You just need one person to say yes. I would also encourage you to widen the net of the jobs that you're looking at. So, Eric, if you think you want to be a Python dev, I would encourage you to widen that net to also include things like data scientist or data analyst or business analyst, or any role that puts you in the ballpark of maybe being able to write some amount of Python for your job. Because the idea is that you already have working experience. Now you have demonstrated skills. Now you just need to get your foot in the door. And getting your foot in the door as a software developer or software engineer might be your ideal state. But instead of trying to go from like 0 to 60, maybe you can go from 0 to 20, which is like you get hired as a business analyst. Then you become like some sort of data role, right? Then you become an actual full-fledged software engineer, right? So maybe you can make these bridge positions or these small stepping stones towards your actual end goal. That would be how I would approach it. Like today, if I thought I don't want to work in technology anymore, I want to go be a financial advisor. Obviously, there's a set of regulatory constraints you have to work within, but that's how I would attack it. Is I would start trying to build up a portfolio to demonstrate my abilities to do the work of a financial advisor. I would start pursuing the credentials that I needed, and then as soon as possible, I would start applying for jobs that get me tangibly closer to the ultimate destination. And I would just try to leverage my past work experience, and I would try to spin my past work experience in a way to try to convince the person I'm interviewing with that, hey, I have this professional work experience. It's in a different field, but the things I've learned and the experiences I had translate into me being able to do XYZ job for you. And And that's sort of like the sales and marketing aspect of getting a new job is you have to be willing to pitch, you have to be willing to sell, you have to be willing to be persistent, all those things. So those are my thoughts. I hope that was somewhat helpful, Eric. Again, it's much easier said than done. I know from firsthand experience, I've changed careers 4 times, I would say now. I was a personal trainer, then I was a food scientist, then I was a support analyst, then I moved into quality, then I moved into an engineering role. So I know that it's not as easy as it sounds coming out of my mouth, but I think it's definitely doable, and I'm rooting for you. Wait, Steven, did you take a huge break from live streaming for some months because you were back for some weeks now? Yes, I took a break. I just took off like May, like part of April, part of May, I think, maybe part of June. Yeah, I mean, I have a day job, so I don't really make much money from streaming. Probably less than $100. Like I don't know, in the month of, I don't think I made any money in the month of May. I think the most I made from streaming is like $100 in a month. So I do streaming for fun. I make content for fun. It's like creative outlet. Obviously, I would love to have more members or subscribers to my channel. I think it would be awesome to get to like 1,000 members or 1,000, like somehow get to a total of like 1,000. So either, 500 members and 500 subscribers on Twitch or some combination. I think that would be awesome. But lucky for me, I'm able to support my family just from my day job, and I can do all this for fun. So I can kind of take a break if I feel like I don't want to do it anymore. Thanks, mate. It's really helpful. Yeah, of course, dude. I'm here, rooting for you. I mean, I know we don't know each other personally, but I want to see everybody win, so I hope you get yours. And if you ever need encouragement or advice, you can always pop into the Discord. I'm sure there's also people in the Discord server who have kind of either been in similar situations like you or made similar changes like you. And I think one of the most important things to stay motivated is, you need to hear from other people stories of successes, right? You need to see that the thing you're trying to do is possible, and that keeps you motivated and it keeps you optimistic. And you need that on a regular basis, right? You can't just get that motivation once. You got to have the motivation regularly. I always think of I think it's a Zig Ziglar quote. Zig Ziglar. I think he said, what was it? He says, people often say that motivation doesn't last. Well, neither does bathing. That's why we recommend it daily. So if you ever need encouragement or some, bounce ideas off stuff, I think people would be very helpful. That's good. Yes, it is good. It is good. It is good. It is good to have a day job. And streaming's fun. Being able to have a YouTube channel and do content creation is a lot of fun. So it's nice to have options. Sometimes I think the job market is cooked, especially for juniors. Do you think AI changed a lot of stuff on this? I mean, AI definitely has had an impact, I don't think the market's cooked. It's definitely harder, I think the market will likely go through a cycle similar with other technologies. I think there's been periods in the past where people thought software engineering was kind of cooked, and I think you end up with these cycles where you have kind of a flood, a rush of people into technology because they kind of see it as like a quick ticket to a better life and better pay. And then you see at the first sign of economic stress or economic downturns, you see kind of an exodus, or anytime there's a upheaval in the technology industry, you see kind of this exodus of people. The problem with that is like time is a real thing. Death is a real thing. So over the course of the next 5 or 10 years, if the pipeline of people who want to work in technology shrinks, and the people who are already in the field continue to age and get older and exit it, there's going to be a shortage, right? There's going to be a need. So demand will at some point cycle back around, right? This is just like classic market dynamics. So I don't think AI has, and if you look at the data, it's very clear that AI has not reduced the number of software engineers. You actually see that people are employing more software engineers. Granted, I know that those people are largely skewed to looking for more senior folks, but I think there's enough smart, well-meaning people in the industry that recognize you can't have seniors without juniors, right? So you have to make an investment in the next generation of people to be able to fill those gaps. That isn't in any way to try to minimize that looking for a job is difficult. It's just to try to paint more of an optimistic picture that I think there are people who care about the industry. I think there's people who care about the craft. They care about this field, and they want to see early in career people succeed. And there, I think, are people who are going to go out of their way to try to make sure that continues to be the case. People that come to mind are like Mark Russinovich and Scott Hanselman. They've talked about this a lot. Scott Hanselman. And these guys are VPs. Like Scott's a VP of developer advocacy at Microsoft. Mark Russinovich is the CTO of Azure. And they've talked very openly and publicly about this, that as an industry, they have to start figuring out how they're going to fill this pipeline of junior to senior, and they're going to have to be intentional about it. So I think there's opportunity still, right? So that's what this all boils down to. I still think it's a viable career path. I still think that there's opportunity here. Maybe the job and what it is looks different, but I think you can still build a future. At least around me, barrier for entry is mid-level. Yeah, I think right now that's a thing, just given the current narrative around AI. But I think you have to remember, a lot of the people who are the loudest on the internet and are the most public about their opinions are oftentimes people who are marketing and selling stuff. The day-to-day operators, the people who have been working in technology and executing at high levels for 20 years, 15 years, 30 years, these are not people who are out on the internet spewing all their AI concerns or their AI beliefs. They're just going to work and doing the job they've always done. And so I still think there's a bunch of people that are in the industry who still believe in the field, and they still want to see this profession continue to advance and get better. They're not going to just leave early in career folks high and dry. I think there's people who care. So it's a numbers game. You just got to get in front of somebody who says, I want to give you the opportunity, right? I want to bet on you, right? And that just comes down to getting in front of enough people. Which I know sucks because you have to go through interviews and rejection and applications and all that stuff. But
Welcome to the party path.
I'm optimistic. Hey, Obscure Dev, thanks for becoming a sub. That's super nice of you. That's very, very kind. You're the man. Yeah, but it's just become harder as all. Yeah, and I would never try to minimize that, the difficulty of prospecting for a job. It sucks, and unfortunately, I think of Gary Vee a lot of times, where how do I say this in a way that's relatable? Building a compiler is hard. Getting a job is hard. Achieving a six-pack is hard. Lifting 415 on the deadlift is hard. Squatting 315 is hard. But then you're kind of left with this, you're okay, and what? Like, you just gonna not do it now? You just gonna quit, right? It's like, it's hard. All that means is you're gonna have to be even more enthusiastic, more persistent, right? It's like there's only one response. I think what happens a lot of times is people, they kind of commiserate around the fact that it's difficult, it's hard, blah, 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 blah. And that's sort of an excuse to not do things. All right, I completely got distracted by that. But hopefully that was helpful. Hopefully those ramblings were somewhat useful to you. All right, we want to write to a file. That's what we're trying to do. We're trying to build up a list of strings and write to a file. Actually, I don't even think we need to build up a list. I think we can just append to a file, open a file and append to it. So how to write to file in C. C, write files. So we open a new file, write some text, and close it. As a result, when we open the file, it says hello, append content. That's what I want to do. So open it, append text to the file. So this is what I want. How do I create a formatted string in C? Formatted string in C. Yeah, I hope that was helpful, Eric. I wish you all the best of luck, man. Always happy to talk about it more, and whenever you do get that job or you make the move that you want to make, I hope you come back and let us know and we can celebrate you. Clap you up. I think we have to use sprintf. Yeah, that's what I was thinking. Use sprintf. This is not safe, but op asks for ANSI C. Let's see. I have a function that accepts a string. In calling it, I need to create a formatted string on the fly. How do I do this in ANSI C? Yeah, okay. I think this is what I need to do. So let's create our comma set value separated string. So we will do yeah, you're always welcome in the Discord. Always welcome in the Discord. We definitely need char star. And then do we need to allocate? So we want to do int length of stir is going to be equal to sprintf. And we pass null, 0, and then the string we want to create. In this case, we want to create %d, percent, or not %d, that's in the string itself. We want opcode, n, x, y, k. Now the opcode, I think we actually want to print these in hex, right? Because that's how they're represented in our spec, right? These are hex values. Hey Ryan, good to see you, man. How are you? Love your content from one dev to another. Well done, sir. Oh, well, thank you, Ryan. I'm trying to just create my own little corner of the internet over here. You know, it's a small one, but it's mine. Okay, so we're dealing with hex. So that's what we want to print. So let's go ahead and print them that way. So we have to do a dry run of printing to figure out how much of a string we need. I'm actually going to do let's do the header first too. So we'll do int length of headers equals this. Oh, actually, we don't even need to do that. We can just do char star CSV headers equals opcode x, y, kk, like this. And then let's go ahead and open our file. So we'll say this is our file, CSV file pointer, and we do open, and I'll just do opcodes, or let's do IBM logo opcodes dot CSV. Then we have to open it in write mode. And we'll just do that. And then I think if this fails, right, we need to do a null check to see if this fails. Oh, actually, we don't want to open this again and again either. We should open this once. And we'll just let it run for some amount of time, and then whenever we think all the opcodes have been written, we'll kill the program. And then we'll close it. So we'll come down here and say, okay, when we're outside the loop, before we leave, we'll do f.close. And we will close our, what did I call it? CSV file pointer, like that. And then up here, we need to do char star. Oh no, I'm already doing it. So if if CSV file pointer equals null, then something went wrong. Let's just return -1 for now. And then we'll say print line failed to open CSV file for writing. And then down here, we'll actually write to it. So how do we append? Append. Okay, open a file in append mode. So can you combine them? Can you open the file and write in? If you write to a file that already exists, the old content is deleted, the new content is inserted. This is important to know. You might accidentally erase content. So I want to see open and or create and append to file. I'm guessing you have to open it in WA mode. Char star. Yeah, what is the better way to say it? Am I like tipping my hand that I don't know C? Should I be saying char pointer? A pointer of char or something? What would be the what would be the I know C way to say say it? Okay, so we gotta go top up here. Where are we? Where are we? Here we go. Gotta do A, Control O, Control O. Now we'll do so we pass in the pointer to a function called fprintf CSV file pointer. And we pass in CSV headers. And we'll add a new line to this guy right here. Before we do any of this, let's just see if we can create this CSV. Oh, we also need to, if we fail to open, do we need to close? I honestly don't know. If fail to open, do we need to close file and see? It's a character pointer. Okay, that's a better way to say it. I have a character pointer. So you should not call close if it fails to open. I kind of feel like I do that somewhere. Oh, no, I don't. No, I do not. I do not do that somewhere. So we're good. We should be ready to run. Okay, so if we close this, we should have a new file, right? Yep, and we do. What's in here? So we only need to append the headers once, not on every single iteration. On every single iteration. So let's do main.c. We only need to do this one time. Yeah, close only if open is successful. That's good to know. So let's go ahead and write this once here, like that. Oh, it's already 8 o'clock. Dang it, bro. I thought we were going to get a lot further than this today. I feel like I did not accomplish very much. I mean, it took a while to work through the binary stuff because we did that all by hand. Let's just see if we can get the opcodes to the CSV, and then I have to do work. Then I have to do the stuff that actually pays for my life. I have to be a responsible adult. So this is the length. Okay, and then we need to format this. So this will be %x. Is that how you print hex code? That is far. You think that's far? I don't know. I feel like I'm not making as much progress. I really hoped I would have something visual to show you guys by now, but I'm having a good time. Print hex and see. Yes, %x. I also think that I also don't know if we need all of these values probably, but I'm gonna go ahead and print them. So we'll do. I'm just gonna print them as decimal values for now. So how many is that? That's 1. We have 5, right? 1, 2, 3, 4, 5, 6. We have 6. So there should be 5 Ds. So 1, 2, 3, 4, 5, 6. So that tells us our length. Then we can do char star CSV stir, which is going to be malloc length of stir times or +1. Like this. Length of stir times the size of char. If CSV stir equals null, then that allocation failed. And I guess we'll just print line that says failed to allocate memory or CSV string. And again, I guess we'll just return -1 for now. However, if we do succeed, then we want to say F, was it S? What was it? F print F? Was that the name of it? Yes, F print F, which probably stands for print file or file print formatted or something. And then we take in our CSV pointer or CSV. Oh no, we have to, okay. So char star equals, this is CSV stir pointer, and this is CSV star. It doesn't have a return value, that's why. So this will be CSV file, what? File pointer, and then this will be the CSV string. Like that. Oh, and then free, yes, scale. Yes, don't forget to free it. So if we get down here, we need to make sure we free it. Free. Stir. Okay, so now we need to create the string. So we're going to do that by saying s in print at, we're basically going to do the same thing we did up here, only instead of this, we're actually going to pass in our CSV stir like that. I wonder if, can this be extracted to a literal? Could I do char star CSV format equals this? Whoops, that's not the right thing. This. Can I pass that? Crap. I deleted the quote. There we go. Okay. I think that's everything. Should we try to run it? You have to set null back again at the end to stop dangling pointer. Which one? This one? On the free? Hey Mark, what's up, man? Good to see you. Off the pointer still points to the same memory address, but accessing it causes undefined. Yes. Okay, so we do CSV stir equals null. Then set null. Yeah. Okay. You have earphones today, huh? That's new. Do I? No, I always have headphones on usually. I have a new microphone, but I always usually have headphones. Maybe they usually blend in with my hair or something. Okay. I guess let's try to run it and see if I don't. We'll just let it run for a bit. So I think there's a lot of the instructions right there. Now we're back. I think at some point it's just going to stop because we reached the end of memory, but we're not. There we go. And then now let's do. I wonder if do I have Excel on this machine? I actually don't know. IBM logo. I think. Oh shit! I forgot. Did I forget to add a new line? What is all this shit? That's not what I was looking for. That's I know I forgot to add a new line, but that's not at all what I was looking for. So what have I done wrong? What have I? That's not. We got shit. Thank you, Mark, for watching for 3 consecutive streams, man. Appreciate that. I appreciate you guys coming back and keeping me company while I struggle bust through my learnings. I really was kind of confident that I had done it correctly. So what's the problem here? We have %x, %d. We're appending to the file. I am gonna add. I think I am gonna add a break here. Something like if CPU PC is greater than memory size, I think is the name of the constant, then we know we know we've finished. We'll actually do that up here. Yeah, memory size. You like to see fellow programmers suffer. Yeah, it is kind of fun. I love watching people write code live on stream or even in videos too. I just enjoy watching how people solve problems, and I like it when they figure things out, and I always learn something new in the process. It's 8:18. I probably should give up on this. I am going to try to run it one more time now with the new line in there. So remove. Let's see what we get. You're calling sn print twice. Is that? Am I? I thought I had to call it once to get the amount of memory. Oh, because we're printing formatted. Is that what you're saying? Is that what you're saying? Second argument to printf dictates the maximum number of bytes to write to the buffer. Because it's set to 0, printf will write absolutely nothing to CSV stir when fprint is subsequently called the second time you're calling it, so you're getting garbled. So how does sprintf actually work? sprint. String size format. Oh, so I can just use this. Do I need to include the null? Yeah, okay, I need to include the null term. Okay. So let's try that. I added a new line. Let's try that again. CPU undeclared, first use in this function. Oh, because I'm not calling it CPU, I'm calling it chip. Maybe I should reconsider that. Maybe CPU is the more... Okay, so I'm expecting now that the program's going to terminate on its own. Yeah, there we go. So then we'll do... Hey, I think we actually have it. So I think we should be able to remove all the zeros, because those are just... I think that... I don't actually know what 0 means, but I don't think we need to worry about it. And then we should be able to look at each of these hex codes, right? And those should map to instructions. Assuming I understand what the hell I'm doing, these should map to... Whoops, you guys probably can't see those opcodes. These should map to our specification. Woohoo! Yeah, let's go. Actually, Kale gets all the credit for that one, because it would have taken me another 15 minutes to figure out why the heck I wasn't printing what I thought I was printing. So 0 in. Do we see a 0 in? Do we see a clear screen? 0, 0. So I don't know how to map the hex back to the... Do we see a 2? I see a 3. Jump to location in. The interpreter sets the program counter to the address at the top of the stack, then subtracts 1 from the stack pointer. So this is the very first instruction, E0. What does that do? That clears the screen, I'm guessing, right? Yeah, this would be clear screen. Do you guys agree? I knew it was the memory address of CSV stir when it's empty, as it's printing the binary interpretation of data from the current data being held in your memory address that it was in. So it could be, it could even be dangerous. Oh shit. No. Whoopsies. Just over here leaking memory addresses on stream. Yeah, so I think that's what this first opcode is clear the screen. See if I can find another opcode. What's the next opcode? A22A. So that's capital. Oh no, I think that's what's this called? Adder set I equals in. So I think that's a set I operation. This is set K. Yeah. So I think now we just need to go through and figure out what are all the opcodes in here. And then implement just those. Just worry about implementing just those opcodes so we can at least run this thing and then go from there. Agree? Agree? Agree. Hands in, everyone. Hands in. Ready? And break. We'll try to do that. We'll try to do that tomorrow morning. And what I'll do tonight is I'll try to go through here and just parse out which opcodes we need. And then tomorrow we'll come in and we'll try to implement all of those, and hopefully we'll be able to see some. Oh, and then we need to figure out how to display it, because I don't know how to display it. So we need to figure that out too. We need to figure out how to use Raylib to draw or to create a display. I appreciate you guys hanging out with me, sticking with me. Kale, thank you very much for chilling and all your help, and super helpful. Got me unstuck several times. Appreciate you guys. Yeah, that's the easiest part. I don't know. None of this is easy, but I'm having a hell of a good time. Weirdly enough. The one thing that does bother me a little bit about it is, am I going to lose my streak on boot.dev? Because I guess I'll just have to keep buying embers, huh? Because I have 21-day streak expires in 2 hours. I think the embers stop me. So embers and frozen flames protect your streak from being lost. With an ember in your inventory, if you are going to lose your streak on Wednesday at midnight, you'll lose the ember instead. Your streak will be safe for one more day until Thursday at midnight. You gain an ember every 3,000 XP you earn in a calendar day based on your time zone. You can have at most 2 embers at a time. If you haven't earned an ember yet, you can still protect your streak with a frozen flame. Okay, so I should be safe. I think I should be safe. I probably won't lose my streak. You can link your GitHub. If you publish to GitHub, your streak continues. Okay, I'll probably do that then. I haven't completed the project, though. So just accept. Make a Stop. Good morning, honey. Just commit like .txt with your progress. Yes. Oh, I did. Okay, so I have been doing that. I have been doing that. So I have been doing that. Also, I'm sorry I screamed like a girl. Yes, good morning to her as well. I'm gonna add, I want a little bit of dopamine, so I'm gonna say write all CHIP-8 IBM logo opcodes to CSV file. That's what we did. Okay. Let's go ahead and ignore the CSV so we don't commit that. And then let's just go ahead and commit everything we've done so far. So chore update git ignore. Chore update to-dos. For added parameters to GCC command, courtesy. Why can't I spell? Is that how you spell courtesy? I think courtesy is COURTSY. Courtesy of @KaleJK. And implemented parsing opcodes and dumping to CSV. So what you're saying, Kale, is since I'm pushing this up to GitHub, I'll actually get credit on boot.dev? Yeah, that's awesome. Hey, you're a legend. Nah, dude, you're a legend. I wouldn't have known about compiling with those warnings, and I definitely wouldn't have figured out how to write it to a CSV for another 20 minutes. Okay. Well, folks, our time together has come to an end. I must go be a responsible adult and do my work at my actual job. Thank you guys for hanging out. It was nice to see you, Kale. Good to talk to you. Good to see you, Mark. Anybody else, if you're still here, I hope you have a wonderful, Wednesday? I hope you have a wonderful Wednesday. If you've already had your Wednesday, I hope it was kick-ass. And I'll see you guys back here tomorrow morning, hopefully. So, all right. Bye. See you guys. Appreciate y'all.